Now let's look at example 10.2, and in this example we're going to look at an actual Monte Carlo simulation model. So it's the same problem like the first one, the deterministic model, where we have the bookstore ordering calendars for sale, and they can get the calendars from their vendors at $7.50 a piece, and we can sell it at $10. Now after January 1st, all the unsold calendars will be sent back for a refund of $2.50. Now in the previous example of the same problem, we assumed that the average demand will be 200. Okay, but now we're going to look at an actual distribution. Okay, the demand is going to follow this discrete distribution. This is a discrete distribution because we have some specific values for the demand, and for each specific value we have a probability associated with that, and the probability is summed to 1. So now we are going to have to generate demand from this probability distribution, not simply assume that it is the average value of 200. Okay, how are we going to do that? So let's go to the Excel file, and remember everything else is the same as the previous example. Only this demand input value is going to be not a fixed value of 200, but a value coming from this probability distribution. So here it is. Okay, the cost and price and refund. Okay, now this is our initial estimate of 200 for the order quantity. Okay, we want to try different order quantities. We'll get to that in a little bit. So this is the number of calendars we're going to order from our vendor. So this is a independent variable. We get to decide what the value of this is going to be. Okay, and here is the given set of demands and the corresponding probabilities. We're going to have to generate demand from this probability distribution. So remember, we have to set up a cumulative probability to the left of the possible values. So that's why your cumulative probability column is to the left here. And we start with 0, and then that plus the probability for 100. Okay. Now we can copy that. So these are the lower limits of the probabilities. So let's give this table a name, and that will be our lookup table. Okay. Now we'll get to these summary statistics and confidence interval in just a little bit. So let's set up the model right here. Okay, and for that let's give some names. That order quantity. Okay, so the first replication. Okay, and let's put the random number in a separate column, but you really didn't have to. You can nest the random number function within our lookup function, but let's do it this way. Now, so demand is going to come from this probability distribution, and that is V lookup of the random number. Okay, remember, this is where you can eliminate column B and put rand left and right parenthesis in here, and that way you don't need a column separately for the random number. And that is the lookup table, and 2 is the second column for demand. Okay. Now this is sales in units, so this is the minimum number, minimum between order quantity and our demand. Okay, that's the sales in units. So return for refund will be how much we order minus how much we sell. Okay, so that's going to be the return. As you can see, whenever I enter a number and press enter, the demand changes automatically because the random number changes, and so the number picked for demand is going to be different as well. Now revenue is sales times selling price, which is that one. Okay. Cost of ordering calendars will be how many calendars we're going to order, because it's not based on sales, it is the number of calendars we order times the unit cost. Okay. Refund is going to come from the number of calendars we return times the refund amount. So now the profit is revenue minus cost, that will be the profit from sales, plus any refund that we will receive. So this is our model. Okay, so if the order quantity is 200, demand is 100, we'll end up losing $250. Okay. Now we want to repeat this for a certain number of replications. Let's say we want to repeat this for 1000 replications. Okay, so 1000 replications, we have to number these. So the easiest way to do this is to first highlight the entire column. Okay, so don't worry that this column goes all the way up to 1 million whatever. Okay, now you go to fill and you say series. Okay, now 1 is the step value. Okay, starting value we have already entered. Step value of 1, and we stop at 1000. And this will generate 1000 rows. Now we copy that. Okay, Control C. Okay, let's go all the way down first, and then press Shift key and end up. Now this will copy that row, first row, to 1000 times. Okay, so now we have 1000 replications of the random number, and for each of the random number we have the demand, and we have the sales and the profit finally. So this is how we replicate simulation. So we have now replicated the demand 1000 times. Now we can use these profits from 1000 replications to find how often each profit occurs and what is the average profit and so on and so forth, which we will look at in the next video.